welcome to today's class. In today's class, we shall be looking at rational inequality part 3. Rational inequality part 3. Before now, we have done rational inequality part 1. We have done part 2. So today's class is part 3. If you have not gone through rational inequality part 1, part 2, I would advise you go through it before coming over to rational inequality part 3. Go through part 1, part 2 before coming over to part 3 so that you understand it better. So solve the inequality 1 over x is greater than 3. What we do at this point is that we multiply both sides by the square of the denominator. Multiply both sides by the square of the denominator. So this implies that we will have x squared times 1 over x is greater than 3 times x squared. So this will give us, this will cancel this, then we will be left with x is greater than 3x squared. And if you move this 3x squared over to this side, you have x minus 3x squared is greater than 0. Is greater than 0. This you can factorize. This is now a quadratic inequality. This is now a quadratic inequality. Under quadratic inequality part 1, you have treated something like this. Alright, so if you factorize this, you have x into 1 minus 3x is greater than 0. Is greater than 0. If you go through quadratic inequality part 1, I made a statement that when you have two factors like this, either the smaller bracket will maintain the sign and the bigger bracket will carry opposite sign, or if the quadratic inequality is such that the coefficient of x squared is negative, if the coefficient of x squared is negative, the two of them will maintain the sign here. So since the coefficient of x squared is negative 3, it therefore means that these two factors will carry the same sign, meaning x is greater than 0. Leave a little space for now. 1 minus 3x is also greater than 0. So x is greater than 0. If you solve this, you have, leave a little space. 1 is greater than 3x. So x is greater than 0. Leave a little space. Divide both sides by 3. You have 1 over 3 is greater than x. Of course, this can be written as x is greater than 0. Leave a little space. X is less than 1 over 3. Why is this so? If you look at a number like this, for example, if 10 is greater than 5, if I express 5 first, it means this sign will change. So if I write 5, it will now be 5 is less than 10. So it's the same thing here. What we are having here is 1 over 3 is greater than x. So if I express x first, the sign will change to less than. It's the same thing as that. You can compare that. So looking at this answer, is it possible for a number to be greater than 0 and at the same time less than 1 over 3? 1 over 3 is 0.33. So is it possible for a number to be greater than 0 and at the same time less than 1 over 3? Yes, it is possible. So since it is possible, you use the word and. Use the word and. If it is not possible, you use or. So since it is possible, we use the word and. And for using the word and, it means the solution can be combined. So this can be expressed as since the word and is used, it means the solution can be combined. And so you can write it as 0 is less than x is also less than 1 over 3. So that's the solution for that particular question. That's the solution for that particular question. Anytime the word and is used, it means the solution can be combined. So that's the answer to question number 3. Alright, so please do well to go through rational inequality part 1, part 2 before coming over to part 3 so that you understand it better. And then if you have any comment, you can put it on the comment section. Try to subscribe, like and share. Bye for now.